Structural steel is one of the most sustainable materials on the planet. Not only because of the way it's made in North America, we use a lot of recycled material to produce the steel sections, but then steel in general is 100% recyclable. So when you take a building down, you recycle all that steel. So one of the issues that HSS has is we are made from hot rolled coil. Now, hot rolled coil does come from two different manufacturing sources. It comes from what we call basic oxygen furnace, or the original blast furnace type of steel. But it also is produced predominantly in North America by the electric arc furnace, just like all the other steel sections are. So recycled content is very high in electric arc furnace material, and so therefore HSS that is produced from electric arc furnace has that recycled content, which leads to the lower embodied carbon. And then you add on the other benefits of using less steel. So when HSS is designed efficiently and you use less steel in your project, not only are you using the best steel, but you're using less of it.
Certainly, obviously, there's a lot of math when you're looking at embodied carbon in a building in choosing materials, but I think often in that comparison between materials, what sometimes gets lost is the amount of something that you're using. So obviously it's going to vary by application, but there are times when you're going to be saving a dramatic amount of weight by using more efficient members, especially in the columns. And that's going to potentially have a dramatic impact on the amount of embodied carbon in the structure.
You know, if you're using less steel in your steel frame, it's going to take some weight out of it, which could have an impact on your foundation design, which is generally concrete, which is a higher embodied carbon material, so we can take material out of those systems as well too. So it goes back to that core issue of being as efficient as possible in our design, because that's really how we're going to take carbon out of buildings.